Hi guys, today we're going to be on page 23 in your notes packet and we're going to talk about solving systems of equations. You talked about solving systems of equations using graphing, substitution, and elimination in Algebra 1 with linear equations. Today we're going to take a look at solving quadratic systems of equations. So again, from Algebra 1, we wrote and solved systems of linear equations. Remember that a system of equations means that I've got two or more equations. I call the system. I've got multiple. And we know that we can solve a system of equations by graphing, by using substitution, or by using elimination. Those same strategies from Algebra 1 we're going to use here in Algebra 2 to be able to solve different types of systems of equations. So we're going to start with graphing. So you're going to need your graphing calculators for this. So for our graphing strategy, notice that we've got y equals on each of these. So I won't have to change that input feature on my calculator. But when I'm graphing and looking for solutions for a system, my solutions or solution, however many I have, will be the intersection points for my graphs. Okay, where do my functions intersect? Those are my solutions. So I'm going to go ahead and pull up my calculator here. And I'm going to graph stuff. So I want a graph page. And I'm going to go ahead and graph each of those functions for that first example. So we've got y equals x squared plus 3x minus 7 is that first equation. And then I'm going to hit that tab key to pull up my entry line again. And then our other function is 3x minus 1. So I've graphed my system here, and my solutions will be my intersection points. So if I look for my intersection points, I can see one right about here. So I'm going to hit Menu, go down to Analyze Graph, and I'm going to have this find me that intersection point. So that's at 2.45, comma 6.35. There's one solution to my system. And then I should have, it looks like, another intersection down here somewhere. So I'm going to go ahead and move this graph just a little bit, and I can see that other intersection point. So I'm going to find it using my calculator. Remember, with your calculator, you never have to guess. You can find those places exactly. And my other solution is at negative 2.45, comma, negative 8.35. So I solve this system by graphing and looking for my intersection points. I'm going to go ahead and put my calculator away for just a second, and I can see I've got both of my solutions jotted down on my paper there. I'm going to do the same thing with my next example. So notice for our first example, we have one quadratic, one parabola that we graphed, and one line. Here, for our second example, we actually have two quadratic functions that we graphed. So we'll take a look at what solutions I can see here. So I'm going to go ahead and just make a new page, add a graph, and my first equation is 3x squared minus 4. And again, I'm going to hit the tab key so I can graph another function. This time I've got negative x squared plus 2. Two parabolas there, one opening up, the other opening down, and I can see I have two intersection points. So I'm going to go ahead and find those. So Menu, Analyze Graph, Intersection, and remember, it would be really nice if I could get both of them at once, but it's only going to give me one at a time. So I'm going to go ahead and find one and jot it down on my paper. So that's negative 1.22, comma 0.5. And then my other intersection point, I find the same way, Menu, Analyze Graph, Intersection, and this time I'm just going to focus on the second intersection. So that point is at 1.22, comma 0.5. So I'm going to put my graph away, and there are my solutions jotted down in my notes. Okay, so solving by graphing means that I'm going to graph that system in my calculator and look at where my graphs intersect. The next method we're going to take a look at is substitution. So we want to use substitution to solve our system of equations. That means that we want to have one of our equations, doesn't matter which one, but one of our equations solved to get a variable by itself. Now for the two examples I have here, I already have an equation where y is by itself. So what I'm going to do is go ahead and take the stuff that y is equal to and plug it in for y in the other equation. That's substitution because I'm substituting this stuff in for y. So that would give me x squared plus x plus 1 squared. Notice the only thing that I've changed is the y. Instead of y, I've got x plus 1. And that equals 13. Now here, since I'm squaring, that means that I have to write this twice and distribute. So I have x squared plus x plus 1 times x plus 1. Remember, that's what square means, that thing times itself. So I've got to write it twice and distribute. So that would give me x squared plus 1x plus 1x plus 1. I still have this other x squared in front, and we're still equal to 13. From here, I'm going to start combining like terms. So I've got 2x squared terms. That means I have 2x squared. I've got 1x plus 1x. That would be 2x plus 1 equals 13. Now I've got a quadratic equation, so I want to use one of my quadratic solving methods. If I move the 13 to the other side, this is something that is factorable. I'm going to go ahead and move that 13 over so I can factor it. So 2x squared plus 2x minus 12 equals 0. I'm going to start factoring by taking out my GCF of 2. So if I factor 2 out of each of these, I'm left with x squared plus x minus 6 equals 0. And then x squared plus x minus 6 factors into x plus 3 times x minus 2. Again, we still have that GCF of 2 in front, and we're still equal to 0. From here, I'm going to take each of my factors that includes an x and set it equal to 0 so that I can solve for x. I'm going to do that just up here. So I have x plus 3 equals 0 and x minus 2 equals 0. I don't need to set this guy equal to 0 because it doesn't have an x. And I get x to be negative 3 and positive 2. So I have values for x here, but remember for my solution to a system of equations, I need that corresponding y for each of these x values. So that means I'm going to take each x and plug it in to one of my original equations to solve for y. I'm going to choose to plug into that second equation. That's what I would suggest you do as well. Remember, make your work a little easier if you can. So this would be y equals negative 3 plus 1, and then y equals 2 plus 1. So I would get y equals negative 2. That means one of my solutions is the point negative 3 comma negative 2. And then 2 plus 1 gives me 3. So my other solution would be the point 2 comma 3. So those are the solutions to this system of equations. Now I'm going to solve this second example the same way. So I have in this second equation y equal to something already. Y is already by itself, so I can go ahead and plug that in for y in my second equation, or my top equation, I should say. And just to give myself a little more room, I'm going to start working up here. So that's x squared plus x minus 7 squared equals 7. Now I need to square this, so that's x minus 7 times x minus 7. When I distribute, I have x squared minus 7x minus 7x plus 49. Remember, we still have this other x squared in front, and we are still equal to 7 on the right-hand side. So I'm going to combine my like terms now. X squared plus x squared is 2x squared minus 7x, and minus 7x would be minus 14x plus 49 equals 7. I'm not going to be able to factor this quadratic, so I would have to either complete the square or use quadratic formula. I'm going to go ahead and use quadratic formula on this. So minus 7, minus 7. If you'd rather complete the square, that's fine too. But in order to use quadratic formula, I need to get this into standard form. So 2x squared minus 14x plus 42. That's why I moved that 7 over, so I would have standard form there. And now my a is 2, my b is negative 14, and my c is 42. So if I plug this into quadratic formula, that would be x equals negative b plus or minus the square root of b squared minus 4 times a times c. And this is all over 2 times a. From here, I'm going to start reducing. Negative, negative would be a positive. So I have x equals positive 14 plus or minus the square root of negative 14 squared is 196 minus 4 times 2 times 42 is 336 all over. 2 times 2 is 4. Inside my root here, I would get negative 140. So I have x equals 14 plus or minus the square root of negative 140 over 4. Now, I want to simplify my root here. But first, I want to point out that we're taking the square root of a negative. That means that we're going to get something imaginary. Since we're going to get something imaginary, that means that I would not expect to see any intersection points on this graph. Okay, that means that we're going to have no real solutions. So I'm going to go ahead and simplify this for the practice. So 140, factors of 140, we'll do 14 and 10. 14 would be 7 times 2. 10 would be 2 times 5. So I get some exit buddies there I can pull out. And I would get x equal to 14 plus or minus 2i root 35 over 4. Since this is imaginary, that means I'm going to have no real solutions for this system. When we've been solving polynomials, if we got an imaginary solution, we just stated what that imaginary solution was. Here, since we would have to plug that imaginary back in to solve for y, and an imaginary solution isn't something we actually can list as an ordered pair on the real coordinate plane, we're going to go ahead and just say no real solutions for this. So we've looked at graphing, we've looked at substitution. Now let's go ahead on the next page and look at elimination. So remember, the big idea for elimination is that I am able to add my equations together, and when I do so, eliminate one of the variables for my problem. So if I take a look at this first example here on page 24, I want one of my variables to have opposite coefficients. So same number, but opposite sign. If I take a look at my y squared terms here, I've got positive 1y squared and negative 1y squared. That's exactly what I want, because when I go to add these equations together, y squared minus y squared means that I have no more y squareds left. So I'm going to go ahead and add the rest of my like terms here. So x squared plus x squared is 2x squared minus 16x, since that's the only x term. And then 39 minus 9 would be plus 30 equals 0 plus 0 is just 0. Now I've got something that's just in terms of x, so I can solve for x. This is a quadratic that is factorable. So I'm going to go ahead and pull out my GCF of 2. That leaves me with x squared minus 8x plus 15. And then when I continue to factor here, this quadratic factors into x minus 5 times x minus 3. And then just like we did for that first substitution problem, I'm going to set each factor that has an x equal to 0 so that I can solve for x. So I get x to be 5 and x to be 3. And now again, just like we did for our last substitution problem, I'm going to go ahead and take these values for x and plug them into one of my original equations. I'm going to plug into the second equation because this is a little bit shorter equation. There are fewer places I need to plug in x. It seems like it makes my work a little easier here. So when x equals 5, I would have 5 squared minus y squared minus 9 equals 0. And then I also will need to plug in x equals 3. So that would be 3 squared minus y squared minus 9 equals 0. So as I go to simplify for my first y solution, 5 squared is 25, minus y squared minus 9 equals 0. I'm going to combine my terms here. 25 minus 9 would be 16, minus y squared equals 0. I'm going to go ahead and move my y squared to the other side. Since it's negative, I think it would save me a step if I move the y squareds here. So I get 16 equals y squared. And now we talked about using square roots to solve for x. We're going to do the same thing here. I'm going to take a square root. The square root of 16 would be plus or minus 4. So that means y is plus or minus 4. So when x is 5, y could be positive 4 or negative 4. So I actually get two intersection points, two solutions when x is 5. So 5 comma positive 4, and then 5 comma negative 4. Then I'm going to do the same thing for my x value of 3. So 3 squared is 9, so I get negative y squared minus 9 equals 0. Combine my like terms, 9 minus 9 is 0. So I'm just left with negative y squared equals 0. I'm going to go ahead and divide both sides by negative 1, so I have y squared equals 0. And then again, I'm going to take a square root, and I get y to be, I guess technically if you wanted plus or minus 0, but 0 we don't think of as being positive or negative, just 0. So I only get one solution when x is 3, and that would be the point 3 comma 0. So 3 solutions this time for my system of equations. One more example we're going to take a look at with elimination. This time, we don't already have a variable that will eliminate. So in our last example, our y squared terms had opposite coefficients, but we don't have that here. So what I'm going to do is multiply my bottom equation by 4. I'm going to go ahead and eliminate those y squareds again. You could just as easily eliminate the x squareds, but I'm going to eliminate the y squareds because they have opposite signs right now. That means I just have to multiply every term in that bottom equation by 4. So that would give me 4x squared plus 4y squared equals 16. I haven't changed this because I've done the same thing to every term, multiplied every term by 4. And now I'm just going to recopy that top equation down here. So 9x squared minus 4y squared equals 36. I haven't changed it in any way, I've just recopied it. Now notice my y terms have opposite coefficients. So I can add these together and the y's will eliminate. That's the goal with elimination. Now if I add my like terms, 4x squared plus 9x squared gives me 13x squared equals 16 plus 36 gives me 52. I want to get my x squared term by itself, so I'm going to divide both sides by 13. That gives me x squared equals 4. And now I'm going to solve this using a square root. So take square root of both sides, and then get x equals plus or minus 2. Square root of 4 is 2. So I've got x equals positive 2 and x equals negative 2. I'm going to plug each of those solutions back into one of my original equations to solve for y. Again, I'm going to choose to plug into the bottom equation here. Just seems a little easier to me. If you want to plug into the top equation, you can. So this would be 2 squared plus y squared equals 4. And then negative 2 squared plus y squared equals 4. 2 squared is 4 plus y squared equals 4. I'm going to move this 4 to the other side so I can get y squared by itself. So y squared equals 0. I'm going to take the square root to get y by itself, and I get y equals 0. So I have a solution at 2 comma 0. And then if I take a look at my other x value of negative 2, if I go ahead and solve for y here, negative 2 squared is 4 plus y squared equals 4. I want you to notice these are exactly the same right now. So I'm going to take the same steps to finish solving, and I should not be surprised when I end up with the same value for y. So move that 4 over, I get y squared equals 0, same as what we had here, square root, and I get y equals 0. So my other solution is at negative 2 comma 0. So that's solving quadratic systems by graphing, with substitution, and with elimination.